Hello and welcome back to Functions. First, as always, I want to thank all the nice people that support this channel by liking and subscribing, which helps massively for me to make more videos for you to enjoy. As always, as a small thank you, the PDF version of all lessons is in the description below for you to download for free. Now, in today's part 7, we will start talking about composite functions. Most examples that we have covered in previous videos are composite functions. To understand the idea, I'd like to begin with an example first. Let's consider a radical function given by f of x is equal to the square root of x plus 4. This is a composite function, but why? Let's say I want to find the value of f of 5. That means x is equal to 5. What we get is the square root of 5 plus 4. The first step we would have to take is to calculate 5 plus 4, which is equal to 9. After that, the second step would be to take the square root of 9, where we get 3. Now, since it took us 2 steps to find the value of f of 5, f is going to be a composite function. This means that f can be broken down into 2 simpler functions. I want you to imagine now 2 other functions. One of them, given by g of x, is equal to the square root of x, while the other function is going to be given as h of x, and it's equal to x plus 4. Now the question is, what would happen if I put the function h into g? So that means what I'm doing is g of h of x. This means in the function g, instead of x, I'd plug in the entire expression h. And what we would get is the square root of x plus 4, which is basically our original f of x function. This notation here on the left-hand side denotes a composite function. Another way which this can be written is g small circle h and then of x. You have to read this from right to left, however, because you plug in h into g. Now, the natural question would be, does the order matter? Meaning, what if we flip this? What if we change it into h of g of x? This means that we now are plugging the g function into h instead of x. So what we would get is the square root of x plus 4. Which you can see is a completely different function. So please note that the order definitely does matter. Here, I'm going to give you a short little visualization. Imagine that we have 3 sets of numbers. Now we have a function g which maps set A into set B. And then we have another function h, which is responsible for mapping B into C. Now, if I want to go directly from A into C, I would need a composite function g of h. Basically, the composite function just allows us to skip a step. So let's take a look at 2 examples. We have 2 functions. One of them is f given by 3x minus 6, and the other one is g given by a third of x plus 2. Let's try to find f of g of x first, and then we're going to do the other one. Now, f of g of x means we take the g function and plug it in into f instead of x. What we get is something like this. Finally, all we have to do is open the parentheses. So 3 times 1/3 of x, we get just simply x. And then 3 times 2 equals to 6, and then minus 6. So simplified, all we get at the end is just an x. Now let's try the other way around, g of f of x. This means we take the f of x function and we plug it into g. Now all we have to do is open the parentheses, so we get x minus 2 and plus 2, which is also equal to x. Quite a special case where the order here does not matter, but please note that this is not always the way. Most of the times, the change in order is also going to result in a change of the function. This would be considered a more special case. Okay, now let's consider another example where we have to do the opposite. We have to decompose a composite function into simpler functions. Let's say we have a function p given by the third root of x squared minus 4. The question now is, what two simpler functions, let's denote them by g and f, make up this composite function p? Well, it's clear that one of the functions is going to be what's under the root, the x squared minus 4. So let's just say that g of x is going to be equal to x squared minus 4. This means that the f here is going to be the third root of x. And then finally, when we do f of g of x, we will get the third root of x squared minus 4, which is equal to our original given p of x. Now, please pay attention to the order of the composition, because in this case, if you would have done g of f of x, changed the order, we would have gotten the third root of x squared and then just minus 4, which is an entirely different function. So this is it for now for composite functions. In the next video, we will look into inverse functions, which is another fundamental concept in this series. So I hope to see you there and have a nice day. Bye.